I'm Phil, and today I'm going to have a look at the robot called mBot, and it's made by Makeblock. This is a revival because I looked at this about 5 years ago and haven't done anything on it since. But Chatswood Library are using it in their STEM Club, and we overlap between ozBerry and the STEM Club, and they asked for a little bit of help. They couldn't get their line following program to work. That is, they wanted their robot, mBot, to follow the line of the black line on a robot map. So Chatswood Library is located in Sydney, and I'm going to explore using Block IDE and also give them a demonstration of the Arduino IDE. So what we're talking about is this robot. It's based on the Arduino Uno computer, and it has a few peripherals already on board. For the STEM Club, the robot is already assembled for them. So all they've got to do is program it and test that their applications work. So they'll be looking at coding and robotics. So hardware-wise, mBot, let's have a look at some photos of it. Here's some photos of a basic mBot computer. And on the front, you can see the ultrasonic rangefinder, which is used to detect obstacles in front of the robot. And this one has a battery pack, so you can see the battery pack. And when you get the kit, it comes with all these components ready for you to assemble. You can add more components. You have to get your own battery, and it uses a LiPo battery like this one here. We look at the remote control. The standard remote control uses IR for infrared communications, or alternatively, you can use a Bluetooth or even your mobile phone. There's lots of additional electronic components you can add, including sensors like the ultrasonic sensor and even a climate sensor for temperature and humidity. And you can replace the basic line follower with an RGB line follower. So plenty to experiment with. And with actuators, besides the motor, there's also the liquid crystal display and the 4-digit LED display. And they can be quite useful for debugging your program. So they're the components. Let's have a look at the software. Software-wise, you can either program it in a blocky code, and you can install that on Windows, and it looks a bit like this. So it's called mBlock software, and you can even put it on your mobile phone. Alternatively, with the Arduino IDE, you need to have the drivers installed in both the PC and the mobile if you want to download to the mBot. There are also pre-set modes, and there are 3 of those. The first one is the infrared remote control, and you get that with pressing button A. Button B on the remote gives you the obstacle avoidance mode, and the third one is the line following mode. But to do that, you need to have the firmware, the correct firmware installed, and that's the factory firmware. If you want to work with Block IDE, you need the online firmware. And if you go from one to the other, it's best to do that via the Arduino IDE and download it, compile and download it. So that's software. Let's have a look at some of my projects. So I've installed the software, both the Scratch version of the Blocky program, and I've done a lot of testing, mainly with the DC motors to make sure they work. But the most important program that have been working on is the line follower. And we'll have a look at a couple of these. Let's have a look at this one and what it looks like on the desktop. So this is my mBot on the desk, and you can see what it looks like from different angles. And I've also got a liquid crystal display, LCD display, so that I can debug the program. And I've also got a climate measurement sensor to measure temperature and humidity. So the objective here is to get mBot to follow a simple robot map, which has a black line track, and it's going to follow that track. I also want to provide feedback to make sure the program is going through the correct area, and if there is a problem, I can get help in debugging the program. Safety-wise, I want to be able to stop the robot very quickly, and I'm going to use obstacle detection and stop the robot with the palm of my hand if I want to stop it quickly. Design-wise, I've got the safety aspect of it. For firmware, I'm going to provide names for the different states of the robot. I'm going to provide structured code with functions, and I'm going to use comments to identify the name of the program and help others that want to use the code. Hardware-wise, it all comes from Makeblock, and I'm using the mBot robot. Sensors, I'm using the line follower and the ultrasonic sensor, and that's used for the obstacle detection. The actuators, I'm using DC motors and also a LCD screen. And I need cables, RJ25 cables, and we put it all together. So let's have a look at the software. I'm using mBlock, and the code looks like this. So we might actually go across and have a look at that now. For our software, we're using mBlock, and this is version 5.6. And it has different panels for you to work on. On the right, we have our canvas, or this is where we create our program. And it already has a default for a device called CyberPi. So we don't want that. We're going to use mBot. So we get rid of that one. And we're going to add a device. And there's a list of different devices come up on this menu. The one we want is mBot, which is here. We just click on that, say OK, and it's added. So if you look at in the middle column where your toolkit is, it will show you all the relevant commands that you can use with the robot. Here we've got the action of turning on the motor, and we've got sensing of the line follower and the ultrasonic sensors. Now, what we want to do, since we've got the LCD is not shown here, is that we're going to go and add an extension right on the bottom, and that's going to be added on. And now we've got the TFT, or that's really the extension that we want to use. Okay, so we want to actually start our program. We would instead of, at the moment it's in live, but we want to go to the upload version. When we've got the upload, we can actually, all of these commands are available to us. And what we want to do now is have a look at events. And when we power up and start up our mBot, we can add the other commands. And normally you would initialize, and after you initialize under control, we would then go just repeat that. So we would use a forever. And all we're going to do now is just populate these with the commands that we're interested in. So let's open a previous program. Let's see if we can, we're not going to save that one. We're going to open up a program, and that's already stored on my computer. So we're going to open, and here are all the mBot programs. We're going to use the simple line following program version 11, and it's now loading. Now that it's loaded, we'll have a look at it and see it. We'll zoom out so you can see the full extent of the program, and we'll zoom in. So here you can see it's a structured code where we've got right at the start, when we power up, initialize, and I've created a function here with my blocks. I've got 3 of my blocks, and the first one is initialize the mBot. And the next one is motor control, and the other one is stop and wait. So after we initialize or under initialize, we're setting the ultrasonic distance, the minimum, to 10 centimeters. The motor status is 0, and we're putting some information on our liquid crystal display. And then we wait until we press the button on mBot. And when that's done, we then show a different code as we're moving through our program. That code goes onto our LCD, and we also show on the LED that we're progressing with the RGB color green. And if that's okay, we then go to motor control. And under motor control, we only proceed if the line follower is, let's see, we only proceed here if the ultrasonic sensor is greater than the minimum distance. If that's true, we do the motor control. And there are, how many cases? 1, 2, 3, 4 cases, depending on the value of our lights in the line follower. So the line follower is going to give us a value of 0, 1, 2, or 3, and we then have different actions. The first one is to move forward. The next one, we're going to move clockwise. When it's 2, we go anti-clockwise, and when it's 3, we're going to go backwards. And that's one of my blocks. And if the ultrasonic sensor is less than the minimum distance, we will stop and wait. And here we just stop moving, show the status on our display, and change the RGB lights to red, and wait until we press the button again before we can proceed. And if that's the case, we set the motor status to 1, and then we can proceed with our motor control again. This is the Makeblock mBot robot, and it's constructed with ports and sensors and motors. If we turn it upside down, you can see the motors. And on port 1, we've got a line following sensor. On port 2, we have the ultrasonic rangefinder. It's used for obstacle detection. On port 4, we've got a temperature and humidity detector, the DHT11. And on the rear, we've got an colour LCD. And we're going to use the line following program, version 9. The number 6 indicates the status, and that helps with debugging the program. And let's give it a go. So we'll put it over the line, and we'll press the start up button, which is right here. So we got our program compiled and it worked satisfactorily. So the results were, let's have a look at them. We were able to follow the map and we provided feedback so we could trace the progress of our project. And that data was on the display. And design-wise, we could stop the robot quite easily using the palm of our hand. Okay, so that's using the Blocky program. And as an alternative, let's have a look at this version. And here we're going to use the Arduino IDE. Similar hardware, Makeblock, but we're going to use the line follower ultrasonic sensor. I haven't got a LCD screen on this version, but I've got the same motors. Software-wise, I'm going to use the Arduino code, and this is what it looks like. So, and that code comes from the mBlock software. So we might go across now and see how all of that fits together. So in this version of our mBlock program, I'm using the liquid crystal display. Now, I want to get rid of that, so all I have to do is delete all the blocks that reference that. So I'm going to simplify the program, and I think I've got them all now. Nothing is happening in the motor control, and there's nothing happening here. So in this program, we're not using the LCD, and to get the equivalent Arduino program in C++, we simply go to the right and click on the arrow here. And if we look down, it shows you what the code looks like and what libraries. Right on top, we're including all of the libraries. And we simply select all of that, make a copy of it, and go across to the Arduino IDE and paste it in. So just to show a new one, we're going to start a new sketch. And in the new sketch, we're going to select everything, delete it, and paste in the code that we got from the mBlock program. And we need to also select the board, which is a Arduino Uno computer, and we then just check it, see if it will correctly compile. So we have two options, either to verify the compiling, or alternatively we can upload it. So we'll just check that the compiling is working. Okay, so it compiled okay, and you can see how much memory it's using. And that's the Arduino version. So stay tuned and we'll have a look at that operating on the desktop. The code for this version of mBot Line Follower was generated in the Arduino IDE running C++. So let's have a look at its performance. So it's behaving just like The final program is going to use a different line follower. So let's have a look at, and I did this a few years ago. This is my original version, and the one that I did today is on the right, on the left rather. And the line follower has a quad pair of detectors and LEDs. And in this one, I've chosen the green, and it's called the RGB Line Follower sensor. And it's similar. Our goal is to do the same thing, just follow the black line on a robot map. But we're going to use the RGB line follower instead. This is the mBot line following robot, and I've replaced the dual sensor line follower, which is this one. You can see the LED arrays on the bottom there, and I've replaced that with a quad. So it has 4 LEDs and 4 sensors, and we'll see how that performs. And I've also set the color as green for the LEDs. So we'll put that on, and I need to start by pressing the button here, and it's following the line. In the climate program, we're going to measure temperature and humidity of our environment. So if we just open up the project, we'll have a look at what the project looks like. And the key thing is that we're going to measure the air temperature and humidity. So we might bring the humidity just under. We're also going to measure the light with the internal sensor on mBot, and we're going to show the results on the LCD screen. Hardware-wise, the major change is that we're going to use a DHT11 sensor, and that looks like this one. And let's have a look at the code. Our software, we're going to use the Blocky code, mBlock, and it's going to look, here it is here, this is what it looks like. We might go across and have a look at what that looks like in the program itself. Now here's the code for our climate program, and what we're adding is the LCD screen, and that's going to give us the results. It's going to show and display the results of what we measure, and we're using the sensor DHT11. So let's go and have a look at the code. When we start up, we set up the LCD, and I've added 1, 2, 3, 4, 5 blocks. And they're really just functions that help structure our code. So under setup, we set up the display to port 4, and then we're going to add the labels for temperature, humidity, light. And every time we go round the loop, we're going to increase the count value. So I've set up some additional variables, and in forever, we change the count by 1. We then get the temperature and display and change the RGB with a note to announce that we're measuring temperature. We then get the humidity, and it just simply calls up on port 3 the measurement for humidity over here under get humidity. Then we get the light, and that comes from the light sensor on the mBot itself. We then wait and repeat the forever again. And that's the software for our climate program. Here is a demo of using the DHT sensor to measure temperature and humidity. It's gathering the results on port 4 and sending them to the screen. So we have the temperature 19, humidity 26, and we also are using the internal light. And every time we go through a cycle, we're just counting that. And that's the DHT11 on mBot. Our final project is to use a Bluetooth remote control. And I could have done this either with a mobile phone, but I'm going to use a dedicated joystick or a Bluetooth controller with a joystick. And this is what the joystick controller looks like. And the objective is to use the Makeblock Bluetooth remote to control mBot and display the results on a 4-digit display. So this is going to use an LED display and not an LCD display this time. And it's going to provide us some feedback. And the design-wise, I'll be using the ultrasonic sensor hardware, very similar to what we've done before, but we've added this time the Bluetooth remote control. All of the other devices are the same. So let's have a look at the software. Software-wise, our code looks like this. And we might go across and have a look at that in detail now. Here's the code for our remote control using the Makeblock joystick. And it's using Bluetooth communications. So the program, it's similar structure. We initialize the program, then go into the forever. And I've got 2 of my blocks or 2 of my functions. So just to have a look at what we did to initialize, we had to add an extension. And that extension is for our Bluetooth controller. And the way I did that was to download the extra code. Here it is here. It's been added. And it also adds the additional commands. And if you open it up here, you've only got 2 of them. You've got the joystick controller, and when you press different buttons, you can see that over here, you've got a selection. You can go through, and when you press one of those buttons on the remote control, it can then activate something in your program. And what I'm doing here is to display number 1 on the remote, on the 7-segment display on port 4, and that will stop mBot. If the ultrasonic measurement is less than the minimum distance, it will also stop. Otherwise, it's going to drive the motors. And it's going to it goes through and uses the direction buttons from the remote control to control the motors. So just one example is if the button is up, then it will show number 2 on the 7-segment display and move forward. And the other ones are for either turning clockwise or anti-clockwise or backwards. And that's the code for our remote control of mBot.